Hey everyone, my name is Omer. I'm a solution engineer here at Granulate. And today I'm going to show you the full flow of Granulate's proof of value process or POV process. We start from production profiling all the way to performance improvements and cost reduction. So as an overview, as you can see here, once you initiate a POV process with Granulate, we will first identify the services or workloads that are a good candidate for optimization. You will then run our open source profiling tool, the G Profiler, that will provide you with an upfront analysis and estimation of the performance improvement and cost reduction that the agent will be able to achieve on this cluster. After we identify the potential gains on the service, Granulate will then be installed on a few instances on this service. The agents will then learn the research usage patterns and data flow of the workload for a few days, and then be activated in order to create improved performance. Once you see the value, and the value has been proven to you in a benchmarking call, the client can choose whether you want to expand to the entire cluster or to other services as well. So what we're going to do today is to briefly go over all of these stages. We will first install a G Profiler on our demo environment or demo application, take a look at the flame graphs and the tools as a whole. Then I will show you the optimization demo of me activating an agent on the same workload to improve performance, and then review the result on the G Profiler again. So let's begin. So this is our demo environment. It's a bidding app written in Python. It's 5 servers from one availability zone, giving service to 10 backend services on another availability zone. As you can see, 5 servers. What we're going to do now is we want to understand whether it's a good fit for optimization. So what we want to do is want to install the G Profiler on an instance in this workload to get an estimation of the cost reduction that Granulate will be able to provide. So this is Granulate G Profiler or profiling tool. It's an open source tool that enables you to continuously and with low overhead production profiling on your cluster. So first you can go to profiler.granulate.io, then sign in. I will just sign in with my Gmail account. And once you're in this environment, you can install the G Profiler on a service. You can click on Install Service and then choose your installation method. I will do a Docker installation. I will add a service name, call it Demo3, for example, and click Submit. Then I'll copy the command and then we'll install it on one of the machines from our demo environment. So you see, I've logged into one of the machines, 142. This is this line over here. Then I'm going to just run the command from the Docker and let it run until installation. So now that we installed the G Profiler on our cluster, we can go back to the profiling tool, the G Profiler, go to View, and then click on the demo passive or the passive environment, which the agent were not yet installed on. So you can get a visualization of the different codes. The X width of the bar axis represent the CPU time spent on the function execution and the call stack. And the different colors represent different runtimes and kernel code. So you can get filtering into, for example, Python-based code or services or applications, see how much each of these processes is taking on the CPU. And then you can use that to identify bottleneck and optimize your performance overall. You can also filter based on kernel, so syscontrol, for example. What Granulate allows you to do with this tool is we are able to automatically learn the patterns and data flow, and then estimate the performance benefit that will be derived from the agent optimization. So after you ran the profiler and got this visibility, the Granulate team will reach out to you and let you know how much improved performance is actually available on this service. And then once we decide it's a good candidate for optimization, we'll move forward to install the agents. So now that we installed the G Profiler and we have seen our profiling tool, we can go back and activate the agents to improve performance. So going back to our environment, I will remind you again, this is a bidding app based on Python running on AWS. It's running on 5 machines communicating from one availability zone to 10 machines on a different availability zone. In terms of metrics, each machine is handling about 119 to 122 requests. The P90 latency is at about 46 to 55 milliseconds. the P50 latency is at about 34 to 35 milliseconds, and CPU utilization ignores those spikes that AWS sometimes have, are at about 58 to 64%. So what I'm going to do now is I'm going to log into one of those machines, and I'm going to activate the agent on this machine to create improved performance. In real life, the agent will take a few days of learning before we can actually activate the same way I'm going to do right now. But for the purpose of the demo, the agent has already learned this workload. So I will now just activate the agent. Just for you to see what happens here, I'm loading the kernel module. This is the main module that Granulate optimized by, and optimizing for a utility function of latency. The agent can be set to optimize for a specific utility function. So this could be latency, this could be CPU utilization, or whatever metric that is more important to you in terms of costs. So going back to our Grafana, we can see that immediately after activated on 142, which is the lighter orange line here, with no downtime whatsoever, the orange machine is behaving very differently than the other ones. So it handles a lot more requests, so about 137 requests compared to the 112, 117 of before. The P50 latency dropped significantly to about 24 milliseconds compared to the 34, 35 of before. And the CPU utilization dropped to about 55 to 60%. So we're handling more requests, we're doing it faster in terms of latency, while still maintaining similar levels of CPU utilization. So what happens here, the load balancer just pushes more requests into this machine. But if I would to install or activate the agent on all of the machines, the CPU utilization will drop significantly, which is what will happen on your cluster as well. We will first install on a few machines, you will see the value, and then we'll move forward to expand to the entire cluster to compound the benefits to cost reduction. So now that we improved our performance, we can go back to the profiler and get a visualization of what exact Granulate was able to achieve on this cluster. So we go back to our demo passive, we can filter with kernel and take a look at the actual CPU and other resources that each of these syscontroller is taking, and then compare that to the active after activation service. Here we can see that compared to the passive one, the demo active lines of the control, the syscontrols on the kernel level are a lot thinner. This is because the Granulate agent was able by mutex lock acquisition scheduling and network queue prioritization to drastically improve the way the kernel is actually behaving and taking its resources from the kernel and CPU. And also by allocating the CPU scheduler better, we're able to dramatically improve the performance, which was also visible in the Grafana. So after optimization, we were able to see that the changes are made in the flame graph. You're able to get a visualization right here in the profiler that we already seen on the Grafana. I do want to mention that all of the improved performance that you get while installing Granulate and activating are also visible on our dashboard, the G Center. Once you start a POV process with Granulate, you will receive a registration link from one of our solution engineers, and then you can access the G Center and get a visualization of the actual cost reduction. So you can see here a specific service. This could be the backend service or the demo service, and the actual changes between passive, which is the gray line, and active machines, and get the actual calculation of throughput increase created by Granulate, latency reduction, the actual cost reduction possible by using Granulate, and the dollar save over a period of 7 days. So you can also activate and deactivate agents from this dashboard. We can go to instances. We can get visibility into each instance. You can see here each instance, its size, its metrics, its life cycle and status, whether it's active or passive. And then you can actually activate and deactivate the agents from the 3 dots here using the dashboard. So whatever I've shown you before of activating and deactivating can be easily controlled through the dashboard by each of our clients. So there you have it. We started by profiling the workload to see if it's a good candidate for optimization. Once we got an estimation of the cost reduction, we decided to go for an installation on one machine on the cluster. We've seen the actual cost reduction, the potential available there by reducing latency, increasing throughput, and reducing CPU utilization over the entire cluster. We're able then to also see these improved performance on the flame graph of the G-Profiler. And we've seen now we can also access these results on the dashboard. So this is the full POV process with Granulate. You start from profiling, then you activate an agent on a few machines, see the value, and then you can decide after the benchmark whether you want to expand to the entire cluster. So I hope this was helpful. And if you have any additional questions, you can reach out to any of the team members of Granulate to help you with anything you need. Thanks, everyone.